For as long as humans have been capable of abstract thought, we've wrestled with the riddle of time. We've measured it in seasons and shadows, marked it with sundials and atomic clocks, and built entire sciences upon its arrow. Yet the question has lingered, is time truly fundamental, or is it simply the way our minds make sense of change? Ancient Greeks debated whether or not time was an objective reality or merely a product of the mind. Philosophers such as Kant put it into the domain of human experience, whereas physicists from Newton to Einstein attempted to inscribe it into the language of nature itself. Now, in a revelation that shakes both science and philosophy to their foundations, theoretical physicist Michio Kaku has reopened the debate by proposing that time, at least in the sense we all think we know, may not actually exist. This is not the idle musing of a philosopher over coffee, but a contention based on the foundations of advanced physics with evidence provided by startling new figures from the James Webb Space Telescope, JWST. Kaku, a co-inventor of string field theory and perhaps the most celebrated science communicator of our time, has long toyed with the possibility that time is not a fundamental building block of the universe, but emergent, like temperature, which is created by the collective motion of molecules. In most everyday experience, time is felt as linear, flowing from past to future like a river. But in some quantum theories, time is not a fundamental coordinate. Rather, it arises from the interactions of more fundamental, timeless phenomena. For many years, such ideas existed mainly on blackboards and in scholarly papers. But JWST, with its unprecedented power to look across space and, by the nature of light, across time, has provided images and information that make Kaku's speculation more difficult to dismiss. The telescope had been built to look back to the initial billion years after the Big Bang, actually, back to the exact moment galaxies started forming. What scientists hoped to discover were disorganized, clumpy galaxies just entering their cosmic adolescence. It showed something profoundly bewildering instead, fully mature, well-developed galaxies in existence a mere few 100 million years following the Big Bang. These aren't galaxies with a small handful of stars, they have intricate structures, rotational kinematics, and stellar populations indicating billions of years' worth of development that had somehow already passed. For astrophysicists, it was like opening up a history book to the beginning of the first chapter and discovering skyscrapers, smartphones, and fully operational cities already established. Our models, based on time as the controlling paradigm for how the universe evolves, suddenly seemed precariously weak. The consequences are mind-boggling. If they existed so early, as complex as these galactic objects are, either their ages are misestimated, our theories of cosmic evolution are wrong, or time itself does not work the way we perceive it to work. It's tempting to attribute this to measurement error. Perhaps these galaxies aren't as old as we believe. Perhaps they coalesced in some uncharacteristically accelerated manner. But each of these solutions meets with difficulty. The chemical makeup of the galaxies, the pattern of their stars, and their spatial arrangement all indicate maturity, not youth. Kaku contends that this is the exact type of observational aberration that drives science into new paradigms. When reality won't fit the equations, he states, we must question the equations, and sometimes the concepts they are based upon. The concept being questioned here is time itself. In some accounts of quantum gravity, string theory, loop quantum gravity, and causal set theory among them, time is not inherent in the most basic description of reality. Rather, it is a sort of statistical or emergent quality, similar to how temperature comes from the motion of molecules. Molecules don't have temperature, it's an average of macroscopic behavior from the microscopic. Similarly, the universe may not have time as an intrinsic property, it may arise out of the interconnections of events. If so, then our impression of a universe evolving from the past to the future may be a byproduct of the way in which we, conscious observers, perceive information. The universe may, rather, be an immobile, immense block where all instants exist simultaneously. Past, present, and future may be all equally real, simply different slices of a timelessness. The JWST data provides a tantalizing nudge toward this likelihood. If early universe galaxies already look mature, then maybe they did not mature in the way we think of it. Maybe our early and late are merely distinct points on a geometry that is not temporal. Historically, the march forward of time is connected with the second law of thermodynamics, the idea that entropy, or disorder, will grow. This establishes what physicists refer to as the arrow of time. Coffee gets cold, stars exhaust themselves, and eggs crack but don't uncrack because entropy is constantly on the rise. But what if entropy is not the cause of time, but merely an emergent property like everything else? In the early universe, things might have been so strange that entropy wasn't as it is now. If galaxies could be constructed out of order relative to our understanding, then maybe it's because the notion of order itself was something different prior to the crystallization of time as we understand it. This train of thought compels us to face paradoxical questions. What does it mean for something to occur before time has been created? Might the Big Bang not be the beginning of time, but rather our entry into a part of the universe where time is one of the accessible dimensions? If time is emergent, then it's not only the equations of physics that need to be redone. Our experience, memory, and sense of self are all constructed out of the fabric of time. We recall the past but not the future. We get older. We make plans. We grieve. In an eternal cosmos, our awareness could function more like a beam of light, shining on various frames of existence without the frames themselves necessarily occurring after another. Birth, existence, and demise may be illusions of progression. All things could exist forever, and what we term living is simply our awareness traversing them. The concept is not new. Philosophers have been writing about the eternal now for centuries, and there already exist some readings of quantum mechanics that suggest a universe in which the flow of time is relative. The catch now is that data, not mysticism, can be driving us to this extreme perspective. This change is not merely philosophical. If time isn't fundamental, then the potential for technology is massive. Quantum computing, for example, already walks a line between sequential and simultaneous processing. A timeless structure could enable computation that is truly instantaneous in a very real sense, providing solutions without waiting for time to elapse in a conventional sense. In navigation, communication, and even in medicine, comprehending an eternal or nonlinear reality may unlock techniques that bypass the speed of light constraint or redefine the way we engage biological processes such as aging. Over the centuries, humanity's grand scientific revolutions have overthrown our dearest assumptions. Copernicus demonstrated that Earth was not at the center of the universe. Darwin demonstrated that humans were not created outside of nature. Einstein demonstrated that space and time were not fixed. Kaku and the JWST can now be poised to demonstrate that time itself, our most primitive coordinate, is not fundamental. Rather than a universe that started, developed, and will close down, we might be living in a timeless geometry where change is an illusion of viewpoint. In this photo, JWST is not looking back so many billions of years. It is looking sideways into another area of the block universe, where what we see as the past is merely another place in an eternally existent space. The mature galaxies that it observes are not too fast evolving to be real, they are just there, just like our own galaxy here. If that is the case, our biggest challenge might not be technological but psychological. Time provides meaning to our lives. Without it, notions such as progress, aging, and even morality are tenuous. In a world without time, the successes and failures of life are not leading towards something, they just are. But there's also a kind of perverse freedom in this perspective. If all moments are equally real, then nothing is ever really gone. All joys, all loves, all triumphs still exist, forever. Death, in a way, is just another point. Of course, we are not of one mind. Most physicists warn that extraordinary claims demand extraordinary evidence, and though JWST's data are impressive, they are not proof positive of an ageless universe. Subsequent observations will put to the test if these old early galaxies are the rule or an uncommon exception, and if other explanations, exotic behaviors of dark matter, unforeseen physics of star formation, can alleviate the tension without disposing of time itself. Nevertheless, the discussion has changed. The notion that perhaps time is not fundamental is no longer the preserve of philosophers or theorists, it's being propelled by the greatest observational technology the human race has ever constructed. As JWST keeps exploring deeper into the universe, it might compel us to face a disturbing but thrilling prospect that our lives, our past, and our world are not moving like a narrative, but alive all simultaneously in some grand, eternal tableaus. And if so, then the age-old question humanity has posed for so long, what is time, is replaced by an even more profound one: what are we, in its absence?